In 1986, Eric Drexler introduced the idea. Nanobots, machines smaller than a human hair, designed to build and replicate. One starts replicating, two become four become millions. And if powered by carbon atoms from the world, these bots could devour all organic matter, trees, buildings, even human flesh, until all that's left is a pile of mechanical goo. This is a theoretical but terrifying scenario known as gray goo. Drexler framed gray goo as a black swan, a low-probability event with massive consequences. He even ran the numbers. One nanobot doubling every 1,000 seconds would produce over 68 billion copies in just 10 hours and could outweigh Earth in under 2 days. In Drexler's view, the plausibility of the gray goo scenario is based on an encounter between bottom-up manufacturing and human error. Whereas traditional top-down manufacturing uses bulk material to produce objects, bottom-up manufacturing, on the contrary, puts objects together atom by atom through the use of molecular assemblers. In order to work fast enough, these nanorobots must be able to replicate themselves, which induces exponential growth. Today's nanotech is cool, but not creepy. We have nanoparticles that deliver drugs to tumors, coatings that make surfaces self-cleaning, super materials stronger than steel but lighter than plastic. We even have DNA origami. Yes, scientists fold DNA into shapes like tiny smiley faces or drug delivery cages. Real science, but self-replicating nanobots? Still science fiction for now. Now imagine nanobots controlled by artificial intelligence. We give it a simple instruction. Replicate yourself. And if the easiest source of atoms happens to be trees, buildings, or people, it won't hesitate to use them. This is known as the Paperclip Problem, when an AI takes its task too literally, even if it means turning the entire planet into raw material. But gray goo isn't the only creepy crawly in the nanotech zoo. Scientists and sci-fi fans have even invented a rainbow of goo. Blue goo alludes to police nanorobots, able to fight and defeat gray goo. That is, if they do not turn into rogue elements. Green goo refers to the ability to use DNA as a computer code and merge nanotechnology with life sciences, thus leading to the possibility of hybrid genetically modified organisms, GMOs, reproducing in an unpredictable way. Environmental activists have warned that green goo might be the more immediate risk because DNA-based nanobots could slip past immune systems, merge with living cells, and spread stealthily before anyone realizes. Khaki or red goo point to nanoweapons built to destroy everything in the enemy's territory at the molecular level. Thankfully, scientists aren't just pushing boundaries, they're also thinking about how to keep things under control. Some experimental nanobots are designed to rely on a signal from a central system. No signal, no movement. Others use materials that naturally break down after a set time or degrade in sunlight, making sure they don't last forever. To avoid unintended spread, many designs feed on rare artificial substances so they can't survive in the wild without special resources. These are smart ideas, but here's the catch. There's still no global agreement or law that says how this tech should be regulated. No treaties, no guardrails. It's a bit like the early days of nuclear research. We saw the potential, but didn't act until it was almost too late. Gray goo is just one face of a much bigger idea, technology run wild. From rogue AI to engineered pandemics, we're getting scarily close to creating things we don't fully understand. But it's not all doom. Nanotech could cure cancer, reverse aging, clean microplastics from oceans, and even terraform planets. Some researchers think nanobots could one day build entire habitats on Mars from local dust. The key is balance. Innovation with caution, curiosity with control. Subscribe for more science mysteries and what-if nightmares.